Hello guys, welcome back to the channel. This is tutorial series number 13 here in Maharlikans code regarding this TSNotify series. This is our small Golang project, guys, so that you can use for your software needs. So probably we need to continue now regarding this what do you call this WebUtil, this command from the Windows. This is the built-in command from Windows, guys, so we need to continue capturing other fields here from event ID, task, level, opcode, keyword, username, and the computer name. So we will do the same here. So just copy over, guys, to just because they are all similar. Okay, and then okay, this is for the I think this one is for the level now. Hold on, guys, hold on, just hold on. On this one we need to get the event ID here. The next one is the event ID, so we will capture the event ID first. So extract the event ID. So these strings.Contains, and then we found out that this one is the event ID, and then but the event ID is quite different, guys, so we need to we need to extract this or convert this, because right now this is currently a string. Everything here thrown from the output is a string. So right now we need to continue, but we need to convert first. Extract the event ID to get the event ID only. Okay, so this is the part here, extracted event ID. Okay, so strings that replace, need to replace first, guys, otherwise is need to massage the data for this event ID. Okay, event ID, and then this one, then we start from the first character there. Okay, -1 evt, then we check the error. String conversion, this is how you're going to convert, guys, from string to an integer value. So right now is using this strconv dot at what do you call this, at oi. Sorry, guys, this one is to convert to integer value, from a string to integer value. So now we need this extracted ID, and then after this you need to check the error again, guys. To nil, then we just put some coloring there, put red. itrlog.Error, then error. Okay, then we store this. Right now we disable here, right? So we need to enable back all these things. So and then I remove this. This is for our early testing. Okay, so I need this evt here, which is the ID. I think I don't have yet. evt ID, event ID. Then this one is wrong. evt, just a short form, guys. evt, then I need to store this. Hold on, guys, is evt also here. Okay, so the evt there, now we save ready, guys. So this one is an integer, so now converted to integer from a string value. We continue with the rest. Extract the task. This one is the task here, guys. This is the next one is the task. So same thing here, we just copy over. This one is the same. Okay, so the moment this one is task only. Should be task, no, task. So then we store the task value. Okay, source logName, source date. Okay, and then I copy this. For the next one is the level, and then I just copy over, guys, so we can task, then level opcode, then probably this one is the level opcode keyword, then username. So up to username, this one is put more, then probably stop for a while. Okay, so we continue. This one is for the level. Okay, so we need to continue here, guys. This one is the level. Okay, the next one is for the opcode. Oh, okay, opcode. It's for the opcode. Oh, this one. Oh, must be the same. Opcode must be the same here. Make it easy to remember. And then the keyword. You need the keyword. Keyword. Then this one. Keyword. Another one is the user. Hold on, guys, hold on, just hold on, just hold on. Okay, user, and then the other one is the username. This one is the user, so keyword, user, we have done. Then two more, which is a username and the computer. So this is for the username. Username. Then we will store this user. No, sorry. This one we've done the user, and then username. Then we store the username variable. Okay. And then the next one is the computer. So we don't need this anymore. This is the last one, because we have already the description there. This one is for the computer. This one is the computer name, guys, so we will capture this as well. So okay, so we have completed all this: computer, username, user, keyword, opcode, level, task, and then the event ID, all these things. Okay, then date, source, logname. So okay, so later we will use all these variables here. Then we finish the description. Okay, so we have done all this. Then we will continue with here. So at the moment, later we will do the testing again, guys. So now we will store this everything to a struct now, guys. Monitored event ID match with the latest event logs event ID. Now we need to match here, guys. We need to loop first. Okay, t arrange, then the task event list. So we need this. Okay, I think it's on top is t or not. It's already t. Hold on. Okay, guys, so now we need to loop through using this event list, guys. This event list is from here. This is from the collection of this is the collection from the config.yaml file. So these are all the settings here, guys. So the configurable from the config.yaml file using this event ID and then the recipients. So we need to loop through all whatever the user is trying to monitor, which event ID we need to monitor, guys. So we need to match with the current whatever the event ID here. We need to look through all these things, and then we find if any matching, for example 102 or 200 or 201. Then if the user try to put here the 100 or whatever the event ID, then we will be matching here, guys. So right now we are looping through this data here, the configurations here. So by using this event ID, and then we need to match with the current main looping here, which is by using this webtutil command from the Windows built-in command, guys. So whatever we scan from our program here, whatever we scan here is the original one. Whatever they scan we found out here, then we need to match this event ID from our config.yaml file. If any 102 at the moment when the execution of this webtutil command from the Windows built-in command, then we can match. If anything match there, then we need to trigger an alert, guys. So these are all the things here. Right now we need to continue, guys. Okay, so right now we are in the loop. So if task event, so we need to check if the s.eventID, this event ID is from the config.yaml file, is exactly equal to evtID, this ID, guys. So this ID here, because we capture the event ID from this and then store to this integer value variable here. So if anything that match here, we need to check now, guys. So check if the event ID already existed from the stored memory map. I just put a note, guys. Add the new task scheduler info to a map. Okay, so we have all these notes, new event, and then just hold on, guys. Event ID, logName. We need to supply all this information, guys. Strings, TrimSpace. Now we need to save all this information, guys. Okay, maybe I just want to copy. It's more faster. Okay. Okay, so I just copy over first, then source, then this variable on top. Remember that we capturing all this information on top first, then we massage all the data there, then we store it into our map, into using this struct first, and then we will go encode this. Okay, event ID. So I need the evt here. This one is not a string, it's an integer. So evt ID, and then all this task is a task. Okay, and then another one is the level, then level, and then opcode. Need the opcode. Okay, this one is a keyword, and then we use this keyword also here. And after this, user, then we use the user variable. Another one is the username, then pair it with the username name. Okay, and then computer, and then with the computer small thing, we need to map all the variable, guys. Description, then we need this description here also, then this one is different, guys, so is sent. Then we need, this is our internal indicator, guys, that is the email has been broadcasted or not. By default we need to set this as a false, because this one is a new event that need to trigger, guys. Encoded bytes, okay. Encoded payload, okay. Coded payload, at the moment we don't have yet. This one is our old one, guys, so hold on for a while. Okay, guys, I added this everything here to capture our time again. I added this add ts. Remember that we have also for the method number 1, which is the decode payload, encoded payload, add, remove, get, all this standard code, guys. So I also copy over here to capture our time, and then just change a little bit, and then get ts, remove ts, all these things. We need to add this as well, guys. So for the method number 2, this is for a different way, because the source is another struct, so we cannot reuse another type of struct, because when we encode, it will capture the original struct, all its fields, what is the types or whatever, all the field name and its corresponding type. So right now, guys, we can continue here. So okay, guys, so we continue. These are all okay. Encoded payload ts, so we all have this now. Okay, so we need to store the new event there. Event, then if error not equal to nil, and then color that magenta. We need to beautify a bit, guys. Okay, itrlog.Error, need to do the error. Okay, so hold on, guys, check if the event ID existed from the map collection. Then we can decode the data by using the go decode the going. Oh, okay, sorry, guys, this is not the proper way. Decode the go encoded bytes. So this part here will be decoded, guys. You know already how to decode, guys, remember? Okay, so we need to use this function here. We have 2 functions, but right now this is for the second method. So we use this event. So our key here for the second method is the event ID, guys. Okay, so is to add. So by default, this is our internal indicator, guys, whether we need to add this new event or not into our map collection. Okay, strings.TrimSpace, new event date. Okay, so this is the first up run only to capture, guys. When you first run, same thing with our first method, we always capture the first. When you run this TSNotify space, then run exactly equal to 0, so we don't have yet. Okay, and then the data is sent is not is false, and then is to add, then we need to add this. Okay, hold on, guys. So another condition here is not existed from the map collection. So if data that event ID is this event ID, guys, is an integer, guys. So we need to condition like this, like a greater than 0. The event ID, there is no 0 there, so it's always greater than the 0, guys. So this is what I know, guys. So leave a comment below if you know. So this is okay. Each event we need to store into our intermediary what do you call this map, guys. So we need to use the v here, the value. Okay, this fmt.printf, guys, is a very useful for us because easily we can convert some types to a different types into a string type. This is printf always return as a string. So right now we need to use this event ID here. Remember, event ID is an integer, so we can straight away use this fmt.printf, then with the corresponding format, which is the percent then v, that stands for value. You can look for this printf, guys. There are so many values there, the formatting there, then you can just use, but for the most common part is we just use the this symbol, which is the percent and then v. So we continue. Okay, then we concatenate, guys. I just put some special character there, underscore there, something, and then our event date time, and then we just check for a while this one. Event ID storage, so we need this, guys. This is our earlier we created this map collection, so we need this event ID here. Okay, this is how we check in Golang, guys, to check from if the key exists in our map or not. Then we just add this to true. If it is not exist in our intermediary map, guys, this is not an encoded bytes. This is just a normal map in Golang, guys. Remember that we created in our early stages in this discussion, we created this map here. This is our intermediary map storage for any existing event ID that we need to look through. We need to check prior to adding into our real encoded bytes and store it into the map there. So this is our intermediary checking here, guys. So this one is not growing memory. This one is not. It will not be grow this collection of the map here. It's just a normal map. Everything is a normal map, but the data inside is also plain. It's also normal. just kidding. Okay, don't be too serious, huh? Okay, so we will continue. Okay, guys, so I use map most common usually, guys, because this remember that in the map previous discussion, maps key is unique. You cannot append multiple the same key there. So that means that I store into our intermediary map here everything, the event ID, the new event ID. If it is by having this combination of this event ID and then underscore and then the event, this is the log date time. This is the date time here, guys. Date time, then it will be combined with the event ID. So okay, later we can have this discussion here later. So we just continue first. Okay, guys, so okay, guys, this is what I mean. I provided some example here, so convert it into the Unix kind of thing, guys. So right now this is our syntax for this event ID that we need to store into our intermediary map. So this is the thing. For example, this is the thrown this is from the what do you call return here. As you can see, this is the date time here, guys. So this format, and then all these things, and then we combine with the p event id here from a new event id here in the what do you call this new data here. There's a new struct, new event that we need to capture and store into our what do you call the map there. Hold on, guys. So we continue, guys. So we're almost done with this function. Okay, a little bit more. Hold on for a while. So we added here already. If it not exists from our map, then we need to add this indicator as true. So now here is the adding part, guys. Add new pending event id to be sent an email notification. Okay, later we will send this. If is to add is true, so we need to provide all this information here, guys. So we need to copy here again, and then okay, I just use this thing again. Okay, guys, so I just want to combine again this variable here, and then event, this is our key. Okay, so again as event expiry, then you can have all these things, guys. So okay, fmt, that's printf, then time.now. Okay, then we add some what do you call 24 format. This is our expiry, guys. So we need to expire from the map. Okay, although it's not so necessary, guys, but we just we need to remove those event id. This is very important also. Sorry, guys, this is important because this one we remember that we are adding this into our intermediary map. Then later we need to take care of that map also to remove those unnecessary key there. We need to set some expiry for at least 24 hours, but it's up to you here, guys, when you're going to expire. Okay, but this one is not many, not many, it's just how many you put here will be like this event id, then there is a date and time. Then if it depends here, if it throws so frequent, then it will grow our intermediary map there. So at the moment we need to take care also in that intermediary map, which is the event id storage. This map, guys, is a normal kind of thing. It's a normal map. We never encoded whatever the data there. Okay, so the event id storage, we need to add this event id, and then as event expiry. So there is only remember that our map is only key and value, key value pairs, all these things, guys. So ts that remove ts first. We need to remove the previous event id from our real database memory, guys. Okay, that's that event id, and then the ink bytes. So later we will notify here. We will notify here later. We need to create that function first, guys. Probably that is our last function here. Okay, but then I put here instead of a millisecond. So later we will have some another function here, which is notify, which is similar to our previous one. Remember, we have this notify me. We need to create the similar for the second method, but with different format. This one is a different here, but for our second method, which is the event ID, there are more data there. Remember that we have so many fields here. We need to incorporate that as well in our email content. So we need to send this as our email content when we send out or broadcast using the email notification. Okay, so that's all for this topic, guys. In our next video, I will create a new one here, the notify me TS, and then there's another remove expiry. Then we need to take care also. We need to remove this storage here when it expires. Then we need to remove delete that key there, because we no longer use that to clean up our intermediary map, which is called the event ID storage here, because we also adding when there is a new event. The key is this date timestamp from this value here, whatever the date here. Then we concatenate with this event ID. So this is our key, and then we will after this we need to create a new function, which is called the notify me TS. We just call TS for the task scheduler. It's up to you. Is this a naming, guys? So naming is important in programming here. Naming also is difficult, but you need to be very specific, guys. Okay, so that's all for today, guys. See you in my next video. Hope you like our tutorial series here in Maharlikans code, particularly this TS notify series, and I hope you have found importance on this software that we are creating from scratch. Then I hope I can impart with you some experience and knowledge here. Then this software TSNotify is very useful for us for those software programming like a C# or any .NET technology that don't have their own heartbeat, that they really rely on task scheduler or any OS kind of thing that don't have this software. Probably don't have the what they call the Go routines and the concurrency kind of programming, which is Go is king for this concurrency and Go routines. We have our own heartbeat, so we don't rely on this Windows Task Scheduler. In our case, we don't rely here by creating or having our own schedule, but we as a Gopher here, Golang programmers, we have our own heartbeat, so we don't really rely on any scheduling part there. Our program itself will run like this. We have this kind of thing, then we just run this as a normal what do you call this scheduling internally in Go. Is a very cheap also and memory efficient. So Go itself will help other programming what do you call like other programs that don't have this, rely on those task scheduling there. If any fail or something, that it never run the program, then we cannot execute that program properly, because they don't have their own heartbeat that it can execute the program by itself. They just need an external scheduling software. In this case is the task scheduler. If that one is fail, then our TSNotify will notify immediately those corresponding recipients. Then they will know the importance of this program, because we don't know yet if this one is fail. This one is very important. for any critical application that must run daily or must run in a very tight scheduling there, like the interval, then we need this TSNotify for us to check this time that any problem may arise there, so that this one will continuously run this application, for example. So thank you so much guys for watching. May God bless us all. Thank you, and bye bye.